Hello world, this is Doug Purcell speaking, and I will be your trainer for this Python series. So let's go ahead and get started. Let's go ahead and update our program so that the user can enter in input that's outside of the constraints of the program. So in this example, if we were building a program to compute the letter grade of a number, then we wouldn't want a number to be greater than 100, and we probably don't want a number to be less than 0. So we want to rule out numbers that are greater than 100 and negative. So we can make a couple of updates in our program. So I'm going to go ahead and copy this by first highlighting everything in this program right here by doing Control+A, followed by Control+C, and then I'll go here in PyCharm and right click, select New, select Python file, and then type in check_user_input. I'm going to cancel that, do Control+V to paste, and then since we don't need the code that's been commented out, we can go ahead and delete it. So let's go ahead and run this to get better clarity on what we're trying to do. I'm going to select run, and then check_user_input. And then I pass it in 101, we get A, do Shift plus F10. I pass in 500, and we again get A. And then I do Control plus Shift one more time, and then I pass in -100, and then we get this sad face. So what we want to replace instead of these messages is we want to print an error statement to tell the user that they cannot pass this input into our program. We do not want this to happen at all. How can we do that? One school of thought is to go ahead and add another if statement. So let's break this process up into 2 bits. Let's do if final_grade is greater than 100, because that way we will check for all numbers that are greater than 100. If that's the case, then we want to print an error message. Invalid input. Enter in num in range 0 to 100. So far, this is right, but the problem with this is that we need a way to stop the rest of this code from executing. Because as of now, if we run this code, then what will happen is that this error message will be printed, but these statements will keep executing. So therefore, A will be printed. So let's go ahead and test this. 200. We get the error message we wanted, but A is still printed. We don't want this to be printed. How can we stop that? We can use a built-in function in Python, which is called exit, which allows us to terminate the program. We can pass in an integer like 0. In this case, we could pass in 200, and then we just get that error message right here. So we now need to update the second branch because we check in to see that the user input is not greater than 100, but we still haven't checked if the user input is less than 0. So we can do that by adding another expression to this if statement. We want to make a compound if statement. Compound means that there's more than one expression. So what can that expression be? If you want to check for all numbers that are less than 0. The second component would be or final grade is less than 0. If that's the case, then we're checking for the upper bound or all the numbers that's greater than 100. And then we're also checking for the lower bound or all numbers that are less than 0. So negative numbers as well. So let's go ahead and test this by running the program. Let's pass in -1. Invalid input, enter a number in the range of 0 to 100. What happens if we put 0? We get a sad face, good. What happens if we put -0.5? We get invalid input, great. What happens if we put 100? Beautiful. So we're getting the right input that we want. So we check the upper bounds, and you also check the lower bounds as well. This is how you can sanitize your program or prevent user input from being added that you do not want to be included or processed in your program. If a series of decisions are required in our program, we may want to consider using nested if statements. Nested if statements are if statements inside an if statement. So let's go ahead and get a better idea of how to apply this in Python. I'm going to right-click, select New, select Python file, and type in nested if underscore statements. So I'm going to put some comments right here to make our code more lucid. So this right here is just an example of a nested if statement. Let's say that x is equal to 5. So if x is greater than 2, go ahead and print x. If x is double equal to 5, print x squared. What is printed? So let's look at line 5. We declared a variable. We have the if statement, if x is greater than 2. So 5 is greater than 2. So the control of the program passes from line 6 to line 7, and therefore x is printed. Fair enough. And the program continues because this if statement was true. So we go to line number 8, which is another if statement. This is our nested if statement. This is where we're 2 levels deep. If x is double equal to 5, print x star star 2, or x squared, which is 25 in this case. So therefore, 5 and 25 will be printed. We can verify this by running the program. We can click on Run, and then select the name of the file. And as you can see, we have 5 and 25. We can nest multiple if statements, and we can nest multiple if-else statements within an if statement as well. So let's say that we have y is equal to 10. Let's write an if statement. If x is less than y, print the less than sign, and then if y is greater than 10, print greater than, else print less than. So these right here are just for practice so that we can understand the logic of how the nested if-else statements work. We will go back to that previous program that we wrote, the check underscore user underscore input, to see how we can apply a nested if statement in a more practical sense. So I'm going to go and highlight this code and do Control+//, which is a keyboard shortcut in PyCharm, to comment out a block of code. I want to keep the x because the x will be used in this code block right here. So y is equal to 10 if x is less than y. So 5 is less than y. So therefore, the less than sign will be printed. And then the control of the program will now pass to line 15. If y is greater than 10, so y is equal to 10, so therefore y is not greater than 10, and therefore the control of the program skips line 16, pass to line 17, and therefore execute line 18. So therefore the less than sign will be printed. So in this case, we run the program, we have 2 less than signs that will be printed. So we can create this branch in our program to execute a different series of statements contingent on what we're trying to accomplish. To better tie together when to apply nested if statements, let's go back to that program that we wrote before. So this is one way in which we can prevent the user from entering input that we don't intend for them to do so. So if we rerun this program and pass in something like 120, which is something that we don't want the user to pass in because we want the user to only pass in values from 0 to 100, we get invalid input, enter in a number in range from 0 to 100. Very good. However, there's a way to solve this problem without using this exit function. So let's go ahead and remove that. So one approach is that we can have this else statement right here, but inside of this else statement, we can shift this code inside of it so that this code is nested inside the if statement. So what exactly did we do here? If final grade is greater than 100 or less than 0, then print this message. Else meaning that if this condition wasn't executed, then the else block means that these statements will automatically be executed. So this is how we can sanitize the program without using the exit function. Because in this case, if the result of final grade is greater than 100 or less than 0, then we will never make it to this branch right here. Let's go ahead and test that. So I'm going to run check underscore user underscore input. I'm going to put 101, and as we can see, we get invalid input. If I rerun that again, let's go ahead and put in -1. Again, we get that invalid input. So the program is working according to plan. Let's go ahead and put 95. Then all right, so we got our program to work. So by nesting this if-else statement inside the else statement, we're able to check user input that we don't want to validate in our program. We don't have to call the exit function because the code will never make it to this portion if this if statement is executed. So this is an example of the practicality of using nested if statements in Python. Let's go ahead and tie together some of the concepts of if-else statements by creating a little fun program. Let's go ahead and create a grocery budget calculator. We can create a new file by right-clicking, selecting new Python file, and we can say grocery budget calc. Let's go ahead and click cancel. We can think about our program before we start writing some code. So for simplicity's sake, let's say that we have a couple of items that we want to get on our grocery list. And let's assume that we know the value of these items. We want to get a dozen of eggs. So we can say that the price is equal to $2.00. We may want to get a gallon of milk. So let's say that the price is equal to $3.27. We may want to get a loaf of bread. That could be equal to $2.50. So bread is equal to $2.50. We may want some pasta. And let's say that a box is equal to $3.50. And we may want a TV dinner. So the price may be equal to $5.00. So we go to the supermarket and we realize that we may want to pick up a couple of dozen of eggs or a couple of gallons of milk. So when we write this program, we could pick up an arbitrary number of food items. So we can generate exactly the quantity of each item that we want to add to our shopping cart by reading the user input, asking them how much quantity of the items they want to add to their cart, and then updating it that way. So let's go ahead and write that functionality. So let's write egg underscore quantity. And we can go ahead and ask the user for how much eggs they want. So how many eggs in your cart? And then I'm going to go ahead and do the same thing for the rest of these. So now let's go ahead and calculate the bill. We can create another variable called bill, set it equal to $0, and then we could say bill is equal to bill plus eggs times the egg quantity. Then we can go ahead and repeat the same process for the remaining variables. So we have the total amount of the bill right here. And then the next thing we want to do is we want to see the budget that the user has. So we can ask the user for this by passing the input function into the floating point, which allows the user to pass in a floating point number into the program. Enter in your budget. So to calculate the bill, let's go ahead and write an if statement. I want to see if the user has enough money. So to compute that, we can say if budget is greater than the bill, right? And therefore what we can do is budget is equal to budget minus bill. And just for information, we can also rewrite this as budget minus equal bill. So both of these are equivalent. The budget is equal to the budget minus bill, or budget minus equal bill. It's just that this right here is a little bit more concise. So either one works. Feel free to use which one works for you. For consistency, I'm going to change this back to budget is equal to budget minus bill. And then I'm going to print a little message. I'm going to print how much money the person have remaining. So I'm going to say budget. Else, if that's the case, then we can conclude that the person doesn't have enough funds. Not enough funds. Let's go ahead and test this. So I'm going to click on run grocery budget calculator. So I'm saying that we have $100 for the budget. We say I have 2 eggs, 1 carton of milk, 1 loaf of bread, 3 boxes of pasta, and 3 TV dinners. So we have $64.73 as a change. So we're within our budget. So to double confirm that this program works, I'm going to go ahead and run this again and put in some input that I know would be too much for the budget. So I'll say that we have 20 dozen eggs, 10 gallons of milk, 100 loaves of bread. Good gosh, I hope this is for a business. And we have 200 boxes of pasta, 100 TV dinners, not enough funds. Okay, so that's kind of extreme in that case. So let's go ahead and improve this program just one more time. Let's go ahead and figure out how much money the person needs in order to fulfill that bill. So to compute that, we can go ahead and put in budget is equal to budget minus bill. And then what we want in this case is we want that result to be positive. So we can print need, and we can use a built-in function in Python called absolute, which will convert that number into a positive one. So I'm going to go ahead and format this. So when we put in a print statement, this data type right here, which is a string, mixed with this data type right here, which is a number, we can format the output by using commas. So that's one way that we can format the output. So I'm going to go ahead and put comma need this dollars. So I'm going to go ahead and run this one more time. I'm going to say that we have a budget of 100. We have 100 dozens of eggs. Everything else would be 0. Not enough funds, need $100. And there you go. So in this example, we went ahead and we created a very simple grocery budget calculator using Python. And then we tied together our newfound knowledge of if-else statements to check to see if the user indeed have the budget to pay for the bill. And then if it didn't, then the appropriate message will be displayed along with how much money the user needs. Sometimes we may want to repeat certain steps in our computer programs. In this case, we want to use what's known as iteration. Computers are very good at doing these repetitive tasks. They can repeat multiple code statements. They can crunch lots of numbers. They can do the repetitive, mundane tasks that humans hate doing and get very bored of. Computers are very efficient and they're very precise in doing these repetitive tasks. And in Python, there are two primary ways in which we can emulate iteration. We can use a for loop or we can use a while loop. So before we get into the code, I'd like to just explain the general syntax of for loops and while loops in Python. So this right here is how the for loop looks. You have the for keyword followed by an expression. What we've learned previously is that an expression is something that can reduce down to a single value, such as true or false. And then that expression must be terminated by a colon. So it's very similar to an if statement in Python. And just like with an if statement in Python, we indent by 4 spaces to create the code block. So the statements that go inside of the body of the for loop will be executed repetitively. So we can go ahead and create a little simple for loop example. So for x is a keyword in Python. N is another reserved keyword that tests for membership. Range is a built-in function that generates a sequence of numbers. We pass in 100, so we're going to generate 100 iterations or cycles. And then if we want to display the output inside of the variable x during each cycle, we could just print x. So that's an example of a for loop in Python. The other type of loop that we're going to take a look at are while loops. So with a while loop, you typically have a counter, something like I is equal to 0. And then you have a reserved keyword with a while loop, just like you do with a for loop in Python. So while followed by an expression. And then within the code block, you have the statements like this. So syntax, while is a reserved keyword in Python, followed by an expression, terminated by a colon, and then indent 4 spaces, and then include the statements. And then typically, with a while loop, you either want to increment or do I is equal to I plus 1, or you may want to decrement or do I is equal to I minus 1. Because if you don't, then you can get inside an infinite loop, which is something that you may or may not want, depending on what you're trying to accomplish. If it's not intentional, then you don't want it. We'll learn more about infinite loops, and then we'll also learn about how to implement both of these loops in the next 2 videos. Let's go ahead and learn how to implement iteration in Python using a for loop. In the previous video, we took a look at some of the syntax of a for loop. Let's go ahead and write some code to make sure that we have that complete understanding. So to kickstart off a for loop, use the for keyword. This is a built-in keyword in Python, just like how the if keyword is used to kick off the if statements. For followed by a variable, let's say x, followed by the keyword n. N is a built-in keyword in Python, just like for. And what n does is a test for membership. So for xn, followed by range. So range is a built-in function in Python, just like how print is a built-in function, or just how type is a built-in function. Range2 is a built-in function in Python, and what it does is it allows us to generate a sequence of numbers. So if I do for x in range 10 followed by colon, then what will happen is that x after the first cycle of the loop will be 0, after the second cycle will be 1, up into 9. So we'll generate 10 numbers, start at 0, going up to 9. So this is something that I will repeat constantly throughout this lesson. And then just like with if statement, we want to indent by 4 spaces. So we want to print x here, and then we hit enter twice. And then as we can see, the result is from 0 to 9. So that right there is the basics of a for loop. So let's go ahead and learn more about how this range function works. Let's say that we don't want from 0 to 9. Perhaps we want from 0 to 10. How can we modify this program so that we will get that number? So we can do for x in range of 11, because when we pass in a number into the range function, we iterate up into that number, but we exclude that number. So in mathematical notation, that number is called exclusive because we exclude it from the result. So one way to look at the range function is we iterate up into it one number short. So in this case, we indent 4 spaces, and then we print x, and then the result would be from 0 to 10. Let's go ahead and learn about more options that we have. So with the range function, we just don't have to pass in one number. We can pass in 2 or even 3. The values that get passed into a function in Python are called arguments. So we can pass up into 3 arguments in the range function. So in this case, we can rewrite this as for x in range 1, 11. And then in this case, we will print start at 1, going up to 11, but excluding 11. So we will print the sequence of numbers from 1 through 11. Now let's say that I don't want to print the numbers on new lines. So we have 1, and then we have a new line, and then 2, and then a new line 3, a new line 4, etc. So let's say that we don't want that. Let's say that we want to print out the results like this. So we want to print the results out on the same line, and we want to space them out. We can accomplish this by using another argument inside of the print function. And that argument will be called the n is equal to the delimiter, or how you want to space out your output. Let's go ahead and implement that. So for x in range 1, 11, let's go ahead and print out x, but let's pass in n is equal to this, which will, instead of print out the results on new lines, will separate it by blank spaces. So as we can see, we get 1, 2, 3, 4, up to 10, separated by empty spaces. Very good. So let's go ahead and take a look at that third argument that we could pass into the for function. We could do for x in range 1, 101, and then we can pass in a third argument of 2. And what this third argument represents is called a skip step. We will generate the range of numbers from 1 to 100, and we will skip by 2 every iteration. So we'll start off with 1, and then 3, and then 5, 7, 9, ... until we get to the very last result. So in this case, we print x. And as you can see, but look at the last couple results: 89, 91, 93, 95, 97, 99, right? So we're skipping by 2 each time. And you can change that skip step to whatever number you want. So let's take another example of iteration. Let's say that you want to repeat some text a certain amount of time. So I want to print out Python, let's say 50 times. I can use a simple for loop for that, for x in range of 50, which means that this loop will iterate 50 times total. And then I can pass in Python right here. And then by doing so, Python is printed 50 times. So as you can see, we can take a very mundane task of printing out Python 50 times on separate statements, and we can wrap that code inside of a for loop and then have the program to repeatedly execute those statements. So whatever statements get put inside the for loop gets repeated that many times. So if you do something like for x in range of 100, then you put, again, Python, and then on the next line, we put rocks. Then we get these alternating statements of Python rocks a total of 100 times. So again, to illustrate the use of iteration in computing, which is why computers are very good at crunching numbers. We can do repetitive tasks, not too good. But computers, they can compute massive range of numbers quite easily. So let's assume that you want to sum the numbers from 1 to 100. How can we go about doing that? If we were to do this by paper, or even using a calculator, it would be very tedious, and it's highly likely that we will mess up a step. However, computers can do this as long as you provide them the correct set of instructions. So we can create a variable such as sum to keep track of what we want to sum together. And then what we need to do is generate the range of numbers that we want to sum. So if we want to sum the numbers from 1 to 100, we could do for x in range 1, 101, which will generate the sequence of numbers from 1 to 100. And then we can sum that with x. So sum is plus or equal to x. So when we print out the result, we get 5050. And just to illustrate the power of computers, you can put in a massive range of numbers. But as long as we have this simple algorithm, we know that our result will be correct. So if we wanted to sum the numbers from 1 through, let's say, 750, we put from 1 to 751, because remember, we start at 1, we go up to 751, but we exclude that number, right? So we're summing the numbers from 1 to 750. And then again, we do sum plus equal to x, and then there you go. So that's a sum of numbers from 1 through 750, and computers can compute that in milliseconds, just to showcase the power of computing. In the next lesson, we're going to take a look at the other alternative of doing iteration, which is using while loops. Let's learn about the second type of loops in Python, which are while loops. To create a while loop, we need a variable to keep track of the iterations. And then we'll use the while keyword, which, like the for and if keywords, are reserved keywords in the Python language. While will be followed by an expression. In this case, let's say I less than 10. And like with a for loop or if statement, we terminate that expression with a colon. Go ahead and indent for spaces, because that's the Python way. And then we can print the value of I. And then this step is very important right here. We need to increment or increase I. So we can do I is equal to I plus 1, or we can do I plus equal to 1 and hit enter twice, and then as you can see, we get the output from 0 to 9. So that's the basic syntax of creating a while loop in Python. Let's look at another example. Let's say that we want to generate the range of numbers from 1 to 100, but we only want to print the numbers that are divisible by 2. Let's first check that logic. How can we confirm that a number is divisible by 2? What operator in Python can we use for that? Should we use the plus sign? Should we use the minus, the forward slash, the percent sign? I think the answer is percent, because that represents modulus. So if I want to see if a number is divisible by 2, I do 5% 2. And this will return the remainder, which in this case is 1, because 2 goes into 5 2 times, with 1 as the remainder. And if you're using the modulus operator, and if there's a remainder, then you can conclude that that number is not divisible by 2. If we do 8% 2, then the result in this case will be equal to 0, because 2 goes into 8 4 times with a remainder of 0. That's what we get. So if we want to test if a number is divisible by 2, then we can use that number percent 2 equal to 0. If that's the case, it's divisible by 2, and we can go ahead and print it. So let's go ahead and try to write a while loop for this. I is equal to 0 while I is less than 100. So this will generate the range of numbers from 0 to 100. And then within this loop, if I percent 2 is double equal to 0, or if I mod 2 has a remainder of 0, let's go ahead and print I. And then last but not least, let's go ahead and increment I by 1. So when we run this program, we get the even numbers from 0 to 100. And we implement that using a while loop. And if you want to check the odd numbers from 0 to 100, then we can go ahead and do a similar type of program. So let's go ahead and reset I back to 0, because I, up until this point, had the value of 100 in it. So we have to reset that value. So I is equal to 0 while I is less than 101. If I percent 2 is not equal to 0, then this will give us a composite number, or a number that is not even. So let's go ahead and print I. Make sure to indent by 4 spaces. And don't forget to increment I. So in this case, we get the range of odd numbers from 0 to 100. As you can see, the output looks good. So what would happen if we write a while loop and we forget to increment or decrement? Increment is when you increase, decrement is when you decrease. Let's go ahead and write a loop that simulates a decrement. So let's say that I is equal to 10. So while I is greater than 0, let's go ahead and print I. And then let's go ahead and decrement I by 1. So I minus equal to 1. So when we print that, we get from 10 to 1. So in this case, we're iterating from top to bottom, while previously we were iterating in an ascending order, going from small, going to bigger. So let's say that we create a while loop, and let's say that we do something like while I is less than 100, and we just want to print I. What is going to happen here? So in this case, as we can see, 0 is keep getting printed, and this is not going to stop. We're in an infinite loop, and this could max out our computer resources if we were generating bigger and bigger numbers, if we were computing some type of program that were calculating factorials. But in this case, this is just a overhead, and we really don't need it. So to get out of this infinite loop, we could just type control followed by C. It calls a keyboard interrupt to terminate that annoying infinite loop. But all infinite loops are not annoying. You may actually need an infinite loop. Let's say that you're writing a computer game and you want the user to be able to keep playing the game after they lose. So they play the game, they lose, you want to prompt the user, do you want to continue? You can do that an infinite amount of times to increase the gameplay and entertainment that the user derives from that game. In that case, you want to use an infinite loop. Let's look at another example. Let's say that you're writing some type of networking program, which typically includes servers and clients. The client constantly is making requests to the server, and then the server must be consistently listening to the client to accept those requests and process it. So in that case, the server-client relationship is an infinite loop because the server is constantly monitoring for updates from the client. So one scenario in which you may want to use a while loop over a for loop is that you're not really sure how many cycles your loop needs to make. It could be 5 cycles, it could be 10, it could be 100. It's arbitrary. It really depends on what the user wants to accomplish. So in that case, an infinite loop is an ideal candidate. Let's go ahead and write a very simple Python script that asks the user just to enter in a number. So I'm going to create a variable called magic_number, and I'm going to set that equal to int input. So what we're doing again is we're passing the input function into the int function, which requires the user to pass in a number. So enter in a number. So what we can do is we can put this inside of an infinite loop. While true will always evaluate to true, because true can never be false. If that's the case, then the code block within this while loop will keep repeating indefinitely. So I am going to put this inside of this infinite loop and just run it. So I'm passing 100, passing 200, passing 50, passing 9, passing 100 again, etc. So the program will keep prompting me to provide user input. And this is a good program that we can create to really tie together the concept of iteration using a while loop. So next, we're going to go ahead and write a little program to guess the secret number that was generated. Let's go ahead and write a program that tests our knowledge of iteration in Python. But before we do so, I'd like to explain a couple new concepts. So go ahead and create a new Python file. And we're going to name this secret_number. I'm going to cancel out that. And let's learn the purpose of this program. We want to create a number guessing game. The first thing we'll do is we'll generate a random number within the range of 1 to 100. We'll next give the user an opportunity to take a guess. If the user guesses bigger than the secret number, then the program will provide them feedback such as your guess is too big. Or if the user guesses less than the secret number, then the program will also provide the correct feedback, such as your guess is too small. And then last but not least, if the user guesses the secret number, then the secret number will be printed and then the program will terminate. So the user will have an option to guess the secret number. The program will provide the user feedback based on their input, such as if the guess is too big, if the guess is too small, and if the guess is equal to the secret number. If user guessed the secret number, then the program terminates. Let's go ahead and learn how to generate secret numbers within the range of 1 to 100. So Python comes with a module called random. And in that module, we can generate pseudo-random numbers. So I can import random. We don't need to install anything additional. And to test how this works, let's go ahead and call random.randint, which is short for random int. We can pass in the range of numbers we want to generate the random number from. So in this case, we'll generate a random number within the range of 1 to 100. Now, keep in mind that this is different from the range function, right? Because with the range function, we start at 1, we go up to this number, but we exclude that number. So what we're doing is generating a sequence of numbers from 1 through 99. In this case, we'll return in a secret number within the range of 1 and 100, including 100. So these two are different functions, so they work a little differently. So to keep that in mind, let's go ahead and run this program. So as we can see, we run it the first time, we get 94. Run it the second time, get 42. And third time, we get 79. So we're generating these pseudo random numbers. So I'm going to go ahead and store that result in a variable called secret_number and set it equal to that. Go ahead and delete that. So there's one more thing I need to show, which is how to terminate from an infinite loop. Let's imagine that we have a while loop, such as I is equal to 0, and then we have while true, which starts the infinite loop. We want to print the value of I, and we want to increment I every cycle. So let's say that we want to terminate this loop once I is equal to 1000. How can we do that? There's a special statement in Python called break. And what that does is it allows you to terminate or exit out of a loop. So if I do something like if I is double equal to 1000, I'll print a message such as the max is reached, and then I'll provide the break keyword right here. So we should terminate. So let's go ahead and run this to see what happens. So as we can see, we generate a range of numbers starting at 0, going up to 999, and then once 1000 is met, this message, the max is reached. So this statement right here allows us to terminate from a loop. So we're going to need this statement later. So keep that in the back of your mind. I'm going to comment this code out. All right. So we now have the information to go ahead and implement this program. So let's go ahead and create the while loop, because we want the user to be able to provide an arbitrary number of guesses. We want to give them an infinite amount of possibilities to play the game, if that's what they choose to. So we can wrap in our statements within the while loop. And then the next step is, how do we get input from the user? We can create a variable such as user underscore guess and set it equal to int input. Then we can provide them a message. So guess a secret number within the range of 1 to 100. So let's go ahead and just run this program to see what's happening right here. Works according to plan. So I'm going to hit this red square to terminate the program from running. So we had that part set up correctly. So the next step is, how do we provide a user feedback based on their input? So we'll need to compare two variables. We need to compare the secret number with that of the user guess. So how should we do that? We can write if-else statements. So if the user guess is equal to the secret number, then we can print a message. You guessed correctly. We print the secret number, and then we can exit out of this program, because at this point, it is no point in continuing. If the user guess is greater than the secret number, then we can print a message, your guess is bigger than the secret number. Then last but not least, we could print a default message that your guess is smaller than the secret number. And we know it has to be smaller because we only have three options. The guess can only be equal to, greater than, or less than the secret number. Everything else is a moot point. So let's go ahead and run this program. So let's start at the midpoint at 50. Your guess is smaller than the secret number. So looks like I have to add a bigger number. Oh wow, that was 100% not planned for. But you can run this program multiple times and have fun playing this. It's a very fun game to play, and plus it requires just a few lines of code. Let's go ahead and learn about data structure theory in Python. Data structures are prevalent not only in Python, but in all computer programming languages. They allow programmers to store, process, and manipulate data. Data structures are so important that large tech companies like Google and Facebook typically test potential employees about their knowledge on them. Computers store data. Just look at your disk drive. Look at the files you have on your machine. Look at the amount of data that you consume when you're browsing the web. There needs to be a way for programs to efficiently store and manipulate that data. And data structures are the tools that developers use for that. Let's go ahead and learn more about the theory of data structures in Python. Python has 4 built-in data structures. The first one I'll describe is called a list. And if you code it in other languages like C or Java, then a list in Python is similar to an array. An array is a continuous block of memory. So this is a simple diagram of how a list works. So each of these blocks represents a slot in memory. And the lists also have indexes which correspond to the particular blocks in memory. So this right here represents the first index or the 0 index. This right here represents the first index, the second, the third, fourth, and fifth. And inside of these indexes, we can have values. A list is typically homogeneous, meaning that the values are the same, but you can have different values inside of your list. So this right here are called indexes. And indexes store values. The values are called elements or items. And the important thing to remember with lists is that they're mutable. So this is a keyword that's very important. Lists are mutable because you can modify them. The second type of data structure that I like to discuss is a tuple. Tuples, on the other hand, are immutable, meaning that once you declare them in memory, they can't be modified. And immutability will make more sense when we write some Python code to illustrate the process. A set is a data structure that can only contain unique elements. And then last but not least, a dictionary contains key value mappings. And dictionaries are extremely important data structure in all computer science. Key value mappings. So these are the 4 core built-in data structures in Python, meaning that once you download and install Python, you can use these data structures out of the box. There are third-party data structures in the collection module that serves more specialized use cases. But in this course, we'll just focus on the built-in data structures, which can handle a wide array of different use cases. And the very first one that we'll start with will be the list. Let's learn about the list data structure in Python. To declare a list, I can create a variable called x and set it equal to these square brackets. I'm just going to run this program. And then I'm going to print the type of x. And as we can see, that this belongs to the class called list. So this right here is the most basic list that you can create in Python. The list is empty because it contains no elements. So let's go ahead and add elements to the list. So this is a list with 5 elements, and you can separate each one by using commas. If we wanted to access, let's say, the very first element in the list, then we can use x followed by square bracket 0. This right here is called subscript notation, and you use it when you want to access a certain element in a list. Now the tricky thing to remember is that indexes and lists start at 0. Therefore, to get the very first element in the list, you want to use the 0 index. And to get the second element in the list, you want to get the first index. And to get the third element in the list, the second index, and then so forth. So let's go ahead and create some print statements so that we can view the output. Shift plus F10 for a shortcut to run the program. And as you can see, we get 1, which corresponds to the 0 index. We get 4, which corresponds to the first index. We get 2, which corresponds to the second index. And then we get 100, which corresponds to the 4th index. It's very important that you pass in valid indexes, because if we were to try and access, let's say, the 5th index, then what will happen is we'll get an error because there is no 5th index, because remember, indexes start at 0. So it'd be 0, 1, 2, 3, and 4. This list does not contain a 5th index, therefore we will get an error. Index error. List index out of range. So be very conscious of that when you're learning lists, something that you have to commit to memory, that the very first element maps to the 0 index, and then it increments by 1 with each subsequent index. And in Python, we can also access negative indexes. So I can pass in x square bracket -1. And what -1 will map to is the very last element in that list. So let me go ahead and print this. And as we can see, we get 100. If we do x square bracket -2, then we'll get the second to last element, which in this case would be 10, and then so forth. So Python supports positive and negative indexes. So a couple more properties with lists. We can slice them. Or when you slice a list, you're retrieving a subset of that list. So let's say that you want to just retrieve the very first two elements of the list. What we can do is, again, use the subscript notation followed by the index that we want to start with, which is 0, and then followed by the index that we want to stop at. If we want to retrieve 1, 4, then we need to slice from index 0 to index 1, because it will include 1, 4 and exclude 2. So in this case, x square bracket 0 colon 2, we run this, and as we can see, we get that subset list of 1, 4. Let's go ahead and get some more practice with this slicing notation. Let's say that we want to generate this subset of the list from 2, 10. What will the slice notation look like? In this case, we want to start at index 2, which will give us the value of 2, and then stop at index 4. So in this case, index 2, 3, and then we stop at 4, but we exclude 4, which will return 2, 10, as we can see. If we want to slice the whole entire list, we could just put a colon, and this will retrieve every single element inside of that list. If we want to retrieve all of the elements up into 2, then we can again slice the whole entire list, but in this case, we want to stop at the third index because we want to return 1, 4, 2. So in this case, print x square bracket colon, which denotes that we're starting at the beginning of the list. So we start 0, 1, 2, and we stop here. So we return 1, 4, 2. So we run this. That's the output. And here's a neat little trick that I like to show. So this syntax will also return the whole entire list as well. So if I run this, we get 1, 4, 2, 10, 100. And we could also put in a skip step, which is similar to what we use when we generate a range in a for loop. So in this case, we could again use that square bracket notation. And then what I want to do in this case is I want to skip every 2 items. So we start at 0, and then we skip 2 steps. So we return 1, and then we hop 2. So we go 1, 2, return 2. Then again, we hop 2 more times and return 100. So in this case, we'll return 1, 2, and 100. And if we wanted to slice the whole entire list, but we want to do so in reverse, then we can use the colon format, which slices the whole entire list. But in this case, we pass in -1, which allows us to start at the very last item in the list and then slice it going backwards. So we start at -1, and then we go to -2, then we go to -3, -4, and then in this case -5, and then we stop. So we're going to, in essence, reverse this list because we start at -1, and then we keep returning each subsequent item. So 100, 10, 2, 4, 1. So when we print this, this is the output. So that's enough for slicing lists. And let's look at some more properties. Let's say that you want to reassign a list. Since lists are mutable, we can reassign the values. So if we have x is equal to 1 right here, we can change that value by using the subscript notation. So we can say x of 0 is equal to 200. And then what this would do in memory is it would change the value at the index 0 from 100 to 200. So when we print this, as we can see, we get the list again, but the value at the 0 index has been modified. So go ahead and get more comfortable with the syntax of a list. Go ahead and create a couple more print statements so that you can slice lists, so that you can reassign them, and so that you also index them as well. In the next lesson, we'll discover more properties that we can use with lists. Let's continue to build on our knowledge about the list data structure in Python. So I'm in the Python repo, and I'm just going to create a very basic list of integers. And let's say that I want to test to see if a particular number is in this list. I can use the built-in in keyword in Python, the same one that we use if we were to iterate using a for loop, for example. So if I want to test to see if 4 is in X, I can use for in X. As you can see, the result is true because 4 is indeed a member of the list called X. I can also do another example, 7 in X. In this case, it will be false because this number is not inside this list. So just remember that you can always use this particular keyword if you want to test to see if an item is inside of a list. Now I'm going to switch back to PyCharm, and I'm going ahead to create another list called A, and this list will just contain even numbers. So 2, 4, 6, and 8. So let me learn more about some of the methods in the list. So if I wanted to add another element to the list, I could use the built-in append method. And what this will do is append or add this number at the very end of the list. So when I print it, this will be the result. As we can see, 10 has been added to the list. And remember, we can do this with lists because a list is mutable. Therefore, you can modify it. Let's take a look at some other built-in methods. So if I want to count how many times a particular element occurred in a list, I can use the count method. So if I do a.count and let's say 6, and I'm going to store this result in a variable called b, and then I'm going to print it. And as we can see, the result is 1 because 6 occurred just once in this particular list. I can go ahead and add in 6 again. As we can see, the result has been modified because we have added 6 to the list twice. So remember, if you're using an IDE like PyCharm, you could just type in the variable followed by the dot operator. And then what this will do is it'll allow you to introspect all of the functionality that's associated with this particular type. So let's keep going. We can extend a list by adding another list to it. So if we do a.extend 10, 20, 30, then what will happen when we print this is we'll add this list to A. So this will be the result. There's a difference between append and extend. The extend method allows you to add an additional list, while the append method allows you to add an additional item. So if you try to add more than one item with the append method, then you get an error. And we can go ahead and test that, because as we can see, append takes exactly one argument to given. If you want to insert an element at a particular index, then you can use the insert method. And then to make better sense of how to use these methods, Let's look at the method signature. This right here indicates what are the arguments that we need to pass into this particular method. As we can see, double underscore index and double underscore object. So in layman terms, this translates to insert this object at this particular index. So if we want to insert 100 at the beginning of this list, then we have to pass in 0, 100 into this method. So 0, 100, and then now we have to print A because the insert just modifies the list. So if we want to view it, we have to insert and then we can just print A. As we can see, 100 has been added at the very top of the list. You can pop or remove the very last element in the list. So if we call a.pop, then what happens is the very last element is removed from the list. And then again, we have to print it to see the update. So as we see here, 30 is the very last element in the list. We call the pop method, and then we print the result. And then as we can see, that 30 has been removed. And if you want to reverse a list, you can use a.reverse. So as you can see, this was the list before the reverse. And then once the reverse has happened, this is how the elements look. And we can execute all of this functionality on a list because a list is mutable. Let's go ahead and create another list called odds, which will just contain odd numbers. Perhaps you want to walk through all of the elements in the list. And by walking through, what we really want to do is to iterate over each and every element in the list. We can do that by using one of the built-in iteration methods in Python. We can use the for loop or we can use the while loop. So if I say for x in odds, print x, then what will happen is that the variable x will store each value in the list and then display it to the console. So the result will be 1, 3, 5, 7, 9, and 11. Now let's go ahead and rewrite this using a while loop. We can create a variable in I and set equal to 0. And then we create a while loop while I, and then we want to iterate over the length of odds. So what the len function does is it returns the length or the total number of elements in this particular list. And then what I want to do is to print odds square bracket I, and then increment by 1 each time. So I plus equal to 1. I'm going to put a print statement right here in order to put a new line to separate this output from this one. Because if I don't, then the output will run together. So this print statement with no arguments in it simply just prints a new line. Now I could go ahead and run the program. As we can see, we have iterated over the list using a for and while loop. So now that we know that, we can do something a little bit more interesting. Perhaps we can iterate over the list and we can check to see if that value at that particular index is greater than or equal to a certain value. If it is, we can go ahead and make some type of modification. So let's go ahead and write a while loop that walks through a list. And then if that value at that particular index is greater than or equal to 5, we want to double that result. How can we do that? Well, we can start with a counter and I is equal to 0. And then we can create our while loop. So while I is less than len of odds. And then within this code block right here, we could put an if statement. If odds at square bracket I is greater than or equal to 5, what we want to do is modify it. We want to double the result. So we want to say Oz at position I is equal to Oz at position I star star 2. Then we need to increment the result, so we do I plus equal to 1. So if we were to print out Oz, and again, I'm going to put a print statement right here to separate the output. We can go ahead and run this and see the output. So as we can see, we have 1, 3, and then we have 25, 81, and 121. Let's look at what we had previously. We had 1, 3, 5, 9, and 11. So our little program worked because we squared the results that were greater than or equal to 5 in the list. Let's look at one more example. Let's say that we had an empty list. And let's say that we wanted to build a list that contained the numbers 1 through 100. We can rewrite this, do something like this. But if we needed to type out all the numbers from 1 through 100, that could take quite a bit of time. So there has to be an easier way for us to build our list programmatically. And one way to do that is to use a loop. We know that in order to add an element at the end of the list, we use the append method. So therefore, we can combine a loop with the append method to build our list quickly. So I'm going to use a for loop for x in range 1, 101, and then I'm going to do empty dot append x. And then I could print the result of empty. As we can see, we have generated our list from 1 through 100. So in this lesson, we learned more of the properties of a list. And remember, a list is a mutable data structure in Python because we can modify the elements. Let's go ahead and take a look at another data structure in Python, which is the tuple. In the previous 2 videos, we've learned about the list, which is a mutable data structure in Python. In this video, we're going to take a look at a tuple, which is an immutable data structure. What exactly is immutability? We can go ahead and make more sense of this by writing some simple code snippets. I'm going to go ahead and create 2 tuples, 1, 2, 1, 2, 2, 2, 5. And then I'm going to use a dot. And then as we can see, a tuple has 2 methods. So I'm going to count how many times 1 occurred in this tuple, and then print the result, which will be 2, because we have 1 right here, and then 1 right there. And then if I want to get the index of 2, I can print the result. As we can see, that 2 occurred at the first index here. So this is the basic syntax of creating a tuple. Like with a list, we can separate the elements using commas. But the difference is a tuple uses parentheses, while a list uses square brackets. So let's go ahead and create a simple list. And let's juxtapose a list to a tuple. So if we use c dot to get the list of methods that's associated with the list, as we can see, a list has index and count as well, but it also has append. You can also insert elements into the list. You can extend it, you can reverse it, you can pop, you can clear, you can copy, you can remove, and you can sort. So a list has several more methods than a tuple. The question I have for you Why is that the case? If we go back to the concept of a list, we know that it's immutable. So when we append an element to a list, we're adding an element to it, or we're inserting an element to the list, or we're growing the list by extending that list with another one. So we're modifying that list. That's what these methods do. We can make those changes because that's a property of a list. It is mutable. A tuple, on the other hand, cannot be modified. So when you see just index and count, there's no harm in seeing the index of a particular element in the tuple. You're not modifying it. Or if you're counting the number of occurrences of an item in a tuple, that's fine. Because again, you're not modifying the tuple because a tuple is immutable. So while we're on that topic, let's take up some more properties of a tuple. A tuple can also use subscript notation, just like with a list. So therefore, if we pass in a square bracket 0, we get 1. Or if we pass in a square bracket 1, we get 2. So when we print the result, we get 1 and 2. We can also slice a tuple, or retrieve a subset of it. So if we do b 0 to 2, and print the result, we get 2, 2. Or if we do b 1 colon, then we get a subset starting at this first index and then retrieving the remaining elements. So a tuple of 2, 2, 5. But check this out. What happens if we do b square bracket 0 is equal to 100? Let's go ahead and try and run this program. And look at this. Type error. Tuple does not support item reassignment. And why is that the case? The reason for that is because a tuple is immutable. We can't modify its value in memory, which is what we're trying to do here with this item reassignment. So if we try to do something like that, Python will complain because that violates the property of a tuple. So another question to think about is when to use a tuple over a list. I have a simple answer for you. If you're writing a program that needs to rapidly update data, then use a list. A list has properties for that, and it's built just for that use case. If you have data that doesn't need to be modified a lot, this is a keyword known as constants in some languages, then in that case, go ahead and store them in a tuple because it's more memory efficient. So there's 2 more data structures we need to take a look at. They're sets and dictionaries. Let's go ahead and take a look at a set in the next video, which describes a data structure that only accepts unique elements. A set is a built-in data structure in Python that removes duplicate entries. Let's go ahead and create a set. We use open and closing curly braces for the syntax of creating a set. And then I'm just going to print the result. Then when we do, we get 10, 1, 2, 3. So as we can see, the additional 2 1 elements are removed from the set. So that's the main properties of a set. And we can also do membership testing on a set. So if we want to see if 1 is in X, then the result would be true. And if we want to see if 11 is in X, then the result would be false. And we can go ahead and create 2 small sets. Let's say A is equal to 1, 1, 5. And let's say that B is equal to 10, 1, 6, 8, 55, and 79. Let's explore some of the functionality of a set. If we do A dot intersection of B, then what we do is we'll take the intersection of sets A and B and create a new set, which will be 1, because the intersection takes the elements that are common in both sets. So in this case, the only elements that are common are 1. And we can also denote this by using the ampersand symbol as well. This right here is synonymous with the intersection method. So as you can see, we get 1 here twice because the ampersand and intersection method are synonymous with each other. We can also take the union of two sets by using the union method. So in this case, we'll combine the elements of both sets together. And then we could also represent the pipe symbol, which is the vertical line, as the union operator. And if you want to iterate over a set, you can use a for loop. So for x and a, we could print x, and then we get each element of that particular set. So what's a practical use case of a set? So let's say that we're creating a list, and let's say that we want to remove the duplicate elements from it. There's a harder way and easier way to do that. The easier way is to go ahead and convert the list into a set, because we know that set will only accept unique elements. And then from there, we can convert that set back into a list. There's a built-in constructor called set. So what we can do is we can pass in x into that set constructor, which will convert the list into a set and remove the duplicate entries. We can therefore convert that set into a list again. We're passing the list into a set, which removes the duplicate entries, and then we're converting that result as a list again. So we can go ahead and print x. And as we can see, we have a list with duplicate elements removed. So again, if you're writing a program and if you want to prevent duplicate entries, then consider using the set data structure at your convenience. We're now down to the very last data structure in Python, which is a dictionary. A dictionary, like a list, tuple, and set, contain items. But the main difference between a dictionary is that its items contain pairs, key value mappings. Let's go ahead and get familiar with the syntax of a dictionary. Let's say that we have a dictionary of words. So this right here is one item. This right here is another. And last but not least, we have this right there. So what we have is a dictionary of 3 items. This is one item. This is another. And then last but not least, this is the last one. So 3 items. And then each item is broken down into key value pairs. So we have the key followed by the colon and then the value. And then that's one item. And then we separate that item by using a comma. And then this right here is another key separated by the colon and the value. And last but not least, the key of E separated from the value of earth by a colon. So let's go back and review some terms. The key in a dictionary must be an immutable type. So what we have is a string, and strings in Python are immutable, just like how a tuple is. So the key must be an immutable type, and then the value can be any data type that we want. So in this case, the value is a string, but the value could also be an int. It could be a float. It could be a bool. It could be a list, a tuple, or even another dictionary. That is 100% valid syntax. So we can go ahead and print the output of words by doing run, and then as we can see, we have the dictionary. And let's go ahead and get more acquainted with some of the functionality. So can we subscript a dictionary just like we did with a list or a tuple? The answer is yes, we can. We can use the square bracket notation, and then instead of passing in a numerical index, we can pass in a key. So in this case, we do words square bracket A, which corresponds to this key right here. And then when we print the result, it will be apple. So we can go ahead and write the print right here. And then as we can see, we get apple. And the reason why we do this is because a dictionary indexes its items using keys. It doesn't index items using integers, like with a list or a tuple. So if we want to access a particular value, we need to know the corresponding index. So words square bracket C will give us cook, and then words square bracket E will give us earth. So let's go ahead and print this, as we can see right here. So that's one way that we can access the values in the dictionary. But there's also a second way as well. And that's to use a built-in method, which is get. So we do words.get, and then we pass in A. Then as we can see, we also get apple as well. We do print words.get C, then we get the result of cook. So these are two ways in which we can access the values in a dictionary. And let's keep exploring more of the functionality that's associated with the dictionary type. So we could again use the introspection and just see what we have here. So if we wanted to return all the keys in a particular dictionary, then we can use the keys method. So I can print words.keys. Then what will happen is I'll get A, C, and E right here. The same thing applies if we do words.values. Instead of the keys, we'll get the values, or apple, cook, and earth. And let's keep exploring more of the functionality of a dictionary. So words dot. We can update. So similar to how we can append an item in the list, we can also append an item in a dictionary as well by using this update method. So let's say that we wanted to add a new item. What we must do is we must pass in a dictionary to the update function. So the next word I want to add is a frog. Then when I print words, we can see that the key value pair of F and frog has been added. Because remember, we can't just add a key, or we just can't add a value in a dictionary. It has to be those key value pairs that we add together. So now that we learned some of the basic functionality of a dictionary, how do we go about and iterate over a dictionary? We know how to loop over a list. We know how to loop over a tuple. How can we do the same thing in a dictionary? Doing it with a dictionary is a little bit different. we could do for x in words, and we can go ahead and print x and then view the result. And then by doing so, we get the various keys of that dictionary. But what if we want to get the key value pair? We don't just want the keys, or we just don't want the values. We want both of them combined together. How can we do that? So one way to iterate over a dictionary is to use a for loop for key comma value in words dot items. So dot items is a built-in method for a dictionary, and this will return the key value mappings so that we can store them in these particular variables. And that way, we could print the result. So when I print this, as we can see, we get the keys and we also get the values. Because when we're looping over a dictionary, we're not just looping over a single element, we're looping over the key value pairs. That's why we have these two variables right here to store those corresponding values. So go ahead and experiment with a dictionary. The syntax of it is a little bit more unique compared to the other built-in data structure in Python. But dictionaries are important, they're very flexible, and they're prevalent not only in Python, but in other programming languages as well. In this video training, we got a comprehensive overview of the foundations of Python. We've learned how to get Python set up on our machine. We've learned how to use PyCharm to help expedite the programming process. We've learned about the basic data types in Python. We've learned about control flow. We've learned about iteration, and we also learned about the 4 built-in data structures in Python. A solid foundation in Python will empower you to go out and build more complex and more practical programs. So make sure to keep on coding, to keep on building more interesting things, and to keep having a curiosity about programming and learning, because doing so will help you on your next step of your programming journey. I wish you best of luck.